All right, so welcome back, everyone. We got some news this morning. It wasn't what we wanted to hear, but at least we can get some closure that they did find the body of that missing coal miner in Nicholas County. He was the section boss or foreman of that section, and he was the last off the section. And eyewitness accounts state that he was helping the rest of the men get out of the mine. Sounds about right. For those not in the mining industry, crews that work in coal mines, a lot of times they're with their crews as much or more than they are with their family. And so, because you're psychologically speaking, you're combating these challenging, conditions with, your like a crew. You develop a sense of camaraderie and bonds that isn't dissimilar to combat veterans. And that's actually been told to me by combat veterans, that the reason they like mining is because they still get that sense of belonging, that sense of working together, and that sense of camaraderie, right? So that's a real thing, and everybody I've ever worked for, I believe would do the same thing, right? So with that, let's get into another topic that involves water, another topic that involves flooding. And today, we're going to be talking about Buffalo Creek lessons learned, an introduction to impoundments and tailing dams. So, to start this off, impoundments and tailing dam failures can be catastrophic, not just to mine workers, but to the public and the environment. Okay, so these can be just catastrophic. And in this case, we'll be talking about a little bit about Buffalo Creek, not too far up the road here in Logan County, West Virginia. On February 26th, 1972 at 8 o'clock in the morning, roughly, a coal waste impoundment failed, releasing 132 million gallons of slurry into Buffalo Creek. Out of the 5,000 residents that lived along Buffalo Creek, 125 died, over 1,000 were injured, and 4,000 were instantly left homeless. This was catastrophic. The wall of water that came down Buffalo Creek was 30 feet high and moved at a relentless 6 miles an hour. And a retired coal miner who survived, but lost basically his entire family, explained to the Charleston Gazette, "How I got out of that water, I don't know. I rode the house a long ways. Then I fell off into the water. I finally caught hold of the railroad with one hand and pulled myself out. As I rode that house down the creek, I could see the bottom of it was above those telephone poles in the holler." So this is a huge amount of water. It's coming down this holler that 5,000 people live in. And it was a Saturday morning. But the dams at Buffalo Creek did not meet then current engineering standards and were placed by end dumping. So look at this here. What you have is, and this is an example, we'll talk about this next time, but this is an example of upstream construction. Okay? And so they started the fill down here, coarse refuse, right? And then started putting slurry behind it. But then you put more fill on top of that, and you start over again, right? And just keep doing that over and over again. However, like I said, this dam wasn't really engineered. Okay, it didn't meet the current standards that were in place back then, and it was constructed by end dumping. End dumping is not a good way to make a dam, right? Because you're just dumping in loose material. You're not compacting it. You're not designing it. It doesn't have any sort of a core. Drainage is, not, well designed, right? By doing this. So those were the major mistakes that were done here. Add into that a significant rainfall. The new dam that was just constructed, Dam 3, it fails. Well, what does that do? All that water rushes into Dam 2 and then it fails. And then all that water rushes into Dam 1 and it fails. That's what happened. Impoundment and tailings dam failures are still a global issue. Okay, these are still going on. The Sino Metals leach in Zambia, that released a lot of, I believe this was iron ore. Don't quote me on that, but I believe this was iron ore. And now this has contaminated. It didn't result in any fatalities, but it contaminated the water source for a city of 700,000 people. They actually had to shut the water off to the town. Serious implications, right? Read about it. Find some articles on it, and it'll tell you a lot about what you need to know about this situation. And it's still an ongoing issue, even though this occurred in March. There were 2 tailings dams that failed in Indonesia in February of this year. One of them, as you can see in the top photo, it actually flooded the plant itself, right? So, and two failures. And then there's the Laguna Kinco Dam that failed in Bolivia in March of this year as well. This resulted in 2 fatalities and considerable destruction. Look at all this. So it's still an ongoing issue. However, at least in this country, modern impoundments are engineered and they must be maintained in perpetuity. By that I mean that, just like with the water associated with abandoned mine lands, that sort of thing. Maybe sometimes there's subsidence involved, but one of these days, 100 years, 1,000 years from now, whatever, when we're not mining in this area, anymore, it can, it's going to be that's going to be a long time from now. But at some point, we'll still be working, right? Maintaining all this stuff. So that's where this is going, right? So just like just like with the water situation, where some of these mines are going to be pumping for forever and treating the water. This is another forever kind of thing. Right? So next time, we're going to discuss the types of dams and how they're constructed, and get into sort of the details of that. And with that, we'll see you next time.